Hello! In today's video lesson, you're going to be looking at multiple equations and comparing them and identifying how they are similar and how they are different. What we're going to be able to do is determine the relationship of slopes within multiple equations and how that makes the lines parallel or perpendicular to each other. So we are determining if equations and lines are parallel or perpendicular to each other by only looking at their slopes. Yes, I did misspell a word, believe it or not. I do make a mistake from time to time. So we are not looking at slops, we are looking at slopes. As we go through the video, we're going to use that pink class worksheet to kind of guide us through what I'm going to be discussing. So make sure you have that in front of you as you're going through this video lesson. We're going to start by looking at the group 1, those sets of equations. Looking at each equation, identify their slope and identify their y-intercept. What do all of these equations have in common? In other words, what makes those three equations similar? As you're looking at each of those equations, you're going to be able to identify that the slope for all of those equations is positive 3. I'm going to skip the graphing for now, and I'm going to look down at the bottom of the page. Looking at the set of equations for group 2, let's do the same thing. Let's identify the y-intercept and the slope in all of those equations. You're going to find that the one thing that all of those 4 equations have in common is that they have the same slope. The slope for the equations in group 2 is negative 2. Now I'm going to graph all of the equations on the graphs above, but I'm going to start with the first one, the first set. Before we can really draw any conclusions about what this looks like on a graph, let's plot the actual graph. So we're going to start with group 1, and we're going to put those on the graph here for group 1. Pause this lesson and take a minute to graph each of those equations. When you're done, your graphs will look like this. Now, I did not do a very good job of graphing those because I don't have my stylus with me. So either way, you're going to see that they are all positive. They all point in the same direction. They all have a constant rate of change, which is 3. So each of the graphs is going up 3 over 1, up 3 over 1. And because they are increasing at the same rate, you're going to see that they never intersect. They're always going to increase at that same rate and stay parallel to each other. So let's graph the group 2 set of equations to see if that also holds true, if we do have parallel lines. So pause this for a minute and graph the 4 equations from group 2. When you're done, they're going to look like this. Again, they're as parallel as I can make them drawing on this little app here thing. But they have the constant rate of change of negative 2, so they are each going down 2 over 1, down 2 over 1. So their graphs will never cross, their lines will never cross. They are parallel to each other. So looking at the bottom of my page, I can conclude that if equations have the same slope, that their lines are parallel to each other. So I know that they have the same slope. But what about the y-intercept? Are the y-intercepts the same? Can they be the same? The y-intercepts actually have to be different. If they had the same y-intercept, it would be the exact same line, which is not parallel to one another. So to be parallel, equations must have the same slope, the same m value, and different y-intercepts, different b values. And so what this really says is you're taking the same line. So looking at group 2, you're taking the line y equals negative 2x. And in this one, you're just taking that line and moving it up 4 on the y-axis, moving it up 8 on the y-axis, moving it down 4 on the y-axis. So the y-intercept must be different, but the slope must be the same. Let's flip our paper now to the back side. In this pair of 2 equations, I see y equals 2x and y equals negative 5/10 x. What do these equations have in common? Well, I know that they are 2 equations without y-intercepts, but remember from my objective on the first page of this video lesson that I'm going to be looking at their slopes. Their slopes. And as I look at their slopes, I'm noticing maybe they're related. I can't tell. So I'm going to express them in a different way. I'm going to write them each as a fraction. 2 as a fraction is 2 over 1. Negative 5/10 as a fraction is negative 1 over 2. Well, I see that they have like the same numbers in them and they're switched around and jumbled a little bit. But let's look down at pairs 2 and pairs 3 so that we can see what pattern is evolving. So looking at pair 2, my equation is y equals 4x. My other equation is y equals negative 25/100 x. So let's write each of these in a different way to express their commonalities. Let's write them as fractions. 4 as a whole number as a fraction is 4 over 1. Negative 25/100 as a decimal written as a fraction is negative 1/4. Okay, I'm starting to see a trend. Let's go down to pair 3 and see what happens there. Oops. Okay, pair 3, I have y equals negative 3x plus 5 and y equals 1/3 x minus 1. Again, I'm going to write them as fractions. So negative 3 becomes negative 3 over 1, and 1/3 becomes 1 over 3. As I look back at all of those different pairs, I notice they have the same number, and I notice something happens. I go from a negative number to a positive number, or a positive number to a negative number, positive to a negative, and something else happens. They flip. And so what does that mean in math? There's a special word for that. It is an R word that you used a lot in 6th grade. Think about that as I pull up a page from the internet. One of my favorite quick, easy reference websites is called Math is Fun. I just typed in the word reciprocal, and this is what I got. A reciprocal is simply 1 over whatever number you're given. So if my number is 8, my reciprocal is 1/8. If my number is 5, my reciprocal is 1/5, 8, 1/8, and so on. It's just like this dog is doing right here, turning upside down. So kind of related to what you did last year in 6th grade. In 6th grade, you did a lot of operations with fractions. One operation that you did was dividing fractions. So let's take the fraction 3/5 and divide it by 1/2, for example. When you divided this fraction, in order to solve it correctly, you may have been taught a little jingle or something to remember what to do. What I always would tell my students to do is to flip the second guy and multiply. So 3/5 stays. I'm going to flip the second guy. 1 over 2 becomes 2 over 1, and then I multiply. From there, I solve it, yada, yada, yada. But what I did in this important step right here was when I flipped it, I found its reciprocal. So you've heard of this word reciprocal before. And just to remind you, that's what it means. Now I also checked out my favorite app. My favorite app is called Math Terms, and you should totally download it. It's free. And on the left side, you'll see there's a search column, and you type in any number, any term, and click on that term, and then you're going to get some sort of a definition. This definition is kind of lame. Some of them are a lot cooler. They have like visuals and different movementy things that you can play around with. This one just gives us a flat out definition, and it defines it in the same way as the other website did as well. So it's showing you that the reciprocal, for example, of 5 is 1/5, and it explains why it is what it is. But either way, here's a good resource, a good reference for you to download. It's called Math Terms. Check it out. This sheet is having us graph each equation, but I don't know necessarily what that means so far. So let's pause and let's take a minute to write down the conclusions that we've already drawn from our 2 equations. First of all, from equation 1 to equation 2, I have found the reciprocal of that slope. So the slope is the reciprocal from the first equation to the second equation and going back from the second to the first equation. The slopes are reciprocals of each other. But the important piece to add, do not forget that not only are they reciprocals, they are opposite reciprocals. That's going to be significant when we go to graphing. So let's go back to our pair 1. Let's pause the video and let's graph pair 1's equations. So like I said, pause it and then turn it back on and you can check your work with mine. Pause. And unpause. This is what you get when you graph your two equations. You'll see that they intersect, but they intersect at in a very important way. They intersect at a 90-degree angle, making these two equations perpendicular to each other. Let's see what we get when we look at pair 2. Do we get two lines that are perpendicular to each other? Pause this and unpause it once you have your two graphs written out so that you can compare your work with mine. Pause. Unpause. Here we go again. Our two graphs intersect at 90-degree angles. The two lines form a 90-degree angle, making these perpendicular lines. Let's see if that holds true for pair 3. So take a minute to graph your two equations and see what happens. Pause. And unpause. What do you know? Here we go again. Our lines form 90-degree angles, making these perpendicular lines. So going back to the conclusions, I can conclude that a slope with an opposite reciprocal is significant and it makes perpendicular lines. Fun fact, if you don't remember, the symbol for perpendicular is that. All right, I'm giving you 3 equations, and I'd like you to browse through each of those equations and identify what is the slope, what is the y-intercept. In these 3 equations, there is an imposter. There is one that does not belong. 2 of these are perpendicular to each other. One of them is not. I'm going to cross out the one that is not perpendicular to the other 2 lines. So if you have to pause it to analyze it a little bit, go ahead. But on the count of 3, I would like you to point to the equation that is not perpendicular. Are you ready? 1, 2, 3. Y equals 10 plus 2x is not perpendicular to these 2 equations. They are perpendicular to each other because their slope is opposite and it is a reciprocal of each other. So let's just verify that. Our slope in this equation at the top is negative 2/10. Negative 2/10 as a fraction is negative 1 over 5. 5 as a fraction is positive 5 over 1. So our equation y equals negative 2x plus 5 is perpendicular to our equation y equals 6 plus 5x because the slopes are opposite reciprocal. Now let's try an example with parallel. Here are my 3 equations. Again, one of these equations is an imposter. 2 of them, this time, follow the line or the rule for having parallel lines. So 2 of these equations are parallel to each other and 1 is not. If you need to pause this to look at the qualities of each of these equations before deciding, go ahead. But I'm going to count to 3, and on 3 I'm going to cross out the imposter, and I want you to point to that equation. Are you ready? 1, 2, all right. It is this one, 3. Y equals 8 minus 3x is not parallel to y equals 3x plus 1 and y equals 10 plus 3x. Notice both of their slopes is 3, so those 2 are parallel to each other. Oh yeah, that's the symbol for parallel if you don't remember. So I could say this equation right here is parallel to this equation right here. They have the same slope. This one is also 3, but it's negative, so it would be pointing downward. So I know this was a fairly lengthy video lesson, but I walked you through your classwork, and now you have that as a resource to move on to your homework. Keep in mind that parallel lines have the same slope and a different y-intercept. Perpendicular lines have a slope that is the opposite reciprocal of the other. Now the y-intercept can be the same or different, it doesn't matter, but the slope must be the opposite reciprocal. If you have questions, ask classmates or ask me. Good luck on your homework. And yeah, Hope it went well. See you later.
Made with Doodlecast Pro.